Our location on an island in the Atlantic is part of who we are and part of what's always been important to us. Ireland's temperate climate gives us lots of rainfall and water. That's one of the reasons our agricultural sector thrives. Plus, the seas around us have always provided us with marine, fisheries and other natural resources. As we look to the future, our unique location presents even more opportunities, vital ones, as we strive for renewability and sustainability. Opportunities like harnessing the offshore winds that power their way around and over our island home. We already use onshore wind farms to great effect. In 2020, wind provided for 36% of all our electricity needs. When it comes to offshore, the potential is even greater. Just think of the length of our coastline. It's almost 2,500 kilometres from Cork to Donegal alone. Belgium, with only 63 kilometres of coast, generates 2,000 megawatts with offshore and is planning more. Some offshore development off the coast of Ireland already exists. Now, with new advances in technology and a potential coastline of over 3,000 kilometres, offshore represents one of the main ways for us to reach climate change goals. In fact, it's a crucial element in achieving the government's pledge to generate 70% of our electricity from renewable resources by 2030. There are lots of other economic and social benefits too. Offshore wind power is renewable, so our energy supply would be more secure. Lots of jobs would be created to build and operate the wind farms, and lots of regional economies would be stimulated. Let's look now at ESB's experience with wind power. Since 1994, we've been actively developing wind farms in Ireland and the UK, growing from 5 megawatts in the 90s to over 800 megawatts today. Our wind farms provide clean, renewable electricity to almost 500,000 homes, most of it generated by onshore wind farms. Our journey to offshore started in 2018, and since then we've announced exciting new projects such as an investment in a 350 megawatt Galper wind farm in the UK, a partnership with Park Wind to develop the Oriel and Clogherhead wind farms in the Irish Sea, support for an ambitious 4-year floating offshore wind project off the coast of Mayo, 2 significant joint ventures totalling 1,500 megawatts off the Scottish coast, a strategic partnership with Equinor to co-develop offshore wind assets across a number of sites in Ireland. So, we've talked about why we should develop offshore wind farms. Now let's look at how. The first step is to find a location with optimal wind conditions, so the full power of the wind can be used. Unlike onshore winds, offshore ones aren't affected by mountains or forests being in the way, so they reach a higher, more constant level. The downside is the challenge of building, installing and operating a wind farm in harsh conditions. Next, wind data is gathered over a period of 12 to 18 months. It's part of testing the feasibility of a site to determine how it should be designed. Other factors are taken into account, such as navigation and shipping lanes, gas pipelines, fishing grounds, seabed profile, distance to shore, and accessibility to grid. Also taken into account is the visual impact of the wind farm. It's less than with onshore turbines, but it still must be considered. Another major factor is the water depth and the profile of the seabed. Both affect the design and type of turbine foundation. The most commonly used foundation type are monopile and jacket foundations, and floating foundations for deeper waters. Software is then used to optimize the layout of the turbines, taking into account wake effects and the ideal spacing between them. This is important, especially since offshore turbines are higher in output capacity than onshore ones. Then the construction itself begins. Purpose-built vessels are used to transport, construct, and install the various components of an offshore wind farm. First, steel monopiles are driven deep into the seabed. A transition piece is attached to the monopile. Monopile foundations are suitable for water depths up to 50 metres. For deeper water, other types such as floating, jacket, gravity, or other types might be more suitable. Then, the tower section, blades and nacelle are transported to the offshore site. The base of the tower section is carefully manoeuvred over the transition piece. The tower is lowered onto the transition piece and fixed via a bolted flange solution. Well over 100 bolts are used to fix the tower and the transition piece. This is a very precise and meticulous piece of installation. The nacelle is then lifted into place to be fitted to the top of the tower section. The nacelle houses all the generating components, including the generator, drivetrain, gearbox and brake assembly. It also contains the rotor hub to which the turbine blades are attached. The 75-metre-long blades are then lifted individually and attached to the rotor hub. With high wind speeds and variable sea conditions, this can be very challenging. It requires great levels of skill, precision and experience. Once all 3 blades are installed, the rotor diameter from blade tip to blade tip is 154 metres. Array cables then connect all the turbines to an offshore substation platform. Then, HV undersea cables transfer power to an onshore substation. From here, it's connected onto the grid. That's how the incredible power of offshore wind is harnessed to provide electricity for consumers.